Earth Systems 3209, Unit 1, Introduction to Earth Science, the Evolution of Planet Earth. Reference Chapters 1, 17, and Appendix A. Unit 1, Topic 2.2 will focus on the origin of the solar system. Our primary focus here will be on the origin of the solar system as described by solar nebula hypothesis and identifying the 4 stages of the solar nebula hypothesis. Solar nebula hypothesis in an overview. This idea explains the formation of the solar system through 4 stages. The first stage will focus on all the gas and dust that once existed in the atmosphere contracting to form what we call our solar system. The second stage will focus on the formation of the Sun with the neighboring dust and material orbiting around a centralized portion which will eventually form the protosun. Stage 3 will focus on the formation of the protosun, outlined by all the material concentrating into the orbits. And the fourth and final stage of the solar nebula hypothesis will focus on the formation of the Sun and all the dust and material being blown away by solar winds. Astronomers believe that all parts of our solar system formed at essentially the same time and from the same material. Text references can be found on page 1920 and also on pages 628 to 629. Stage 1, which focuses on the solar nebula hypothesis, says that approximately 5 billion years ago, a huge mass of dust and gas began to contract under its own gravity. This gas cloud began to rotate faster and faster as it contracted. In the diagram, you can see that as the material started to rotate in a counterclockwise direction, the material started to collapse upon itself. Stage 2 of the solar nebula hypothesis focuses on the rotation caused by most material to started to concentrate in the center. The central rotating mass of gases was packing tightly upon itself, and this caused it to heat up and burst into a newborn sun. The remaining dust and gases orbited around the central body as a flattened disk. In stage 2 in the diagram, we can see that the majority of the dust and gas that orbited around the central portion, which eventually formed the protosun, started to flatten and elongate into a flattened disk. Stage 3 of the solar nebula hypothesis states that temperatures within the rotating disk dropped and small particles such as iron and nickel started to form. The iron and nickel particles collided for millions of years, and they accreted to form the planets, moons, and other small bodies that we see today. In this diagram, explaining stage 3, we see the formation of our protosun. Also, we see that the remaining material starts to orbit around our protosun. Stage 4 of the solar nebula hypothesis states that planets accumulated more particles. Space in between the planets started to clear. This clearing of the remaining dust and debris was primarily due to solar winds, which swept the dust and debris away in space. And in the final stage of the solar nebula hypothesis, we see the Sun at the center of our solar system with our orbiting planets and stellar objects rotating around. Let's have a look at some examples of past public exam questions. According to the solar nebula hypothesis, what is the correct sequence of events leading to the formation of our solar system? We have four choices. Choice A states that we had a collection of gas and dust, which eventually formed into a flattened disk, which then formed the sun, which then formed the planets we see today. Choice B states we had a collection of dust and gas, which formed into the planets, which eventually flattened into a disk and formed the sun that we see today. Option C says that we have the formation of the sun, followed by a collection of dust and gas, followed by the formation of planets, followed by the formation of a flattened disk. And option D states that we had the formation of the sun, followed by the formation of a flattened rotating disk, followed by a collection of dust and gas, and the formation of the planets. When we collectively look at all four choices, we see that collection of dust and gas is the first starting point of both choices A and B. Whereas if you look at choices C and D, we had the formation of the sun. So when we look back at the evolution of the solar nebula hypothesis, we notice that the collection of dust and gas would satisfy the first stage in the formation of our solar system. So that would eliminate choices C and choices D. Also, if we go to the very end, which would be the last stage in the formation of the solar system, we see that we had the formation of the planets, or we could have the formation of the sun. But according to solar nebula hypothesis, the planets were the last to form. So by a process of elimination, we eliminated choice C, we eliminated choice D. Therefore, the answer to this problem would be A. A collection of dust and gas, followed by the formation of a flattened rotating disk, followed by the formation of the sun, followed by the formation of the planets. Let's have a look at example number 2. This example focuses on a multiple choice, and it reads, according to the modern theory, approximately how many million years ago did the solar nebula form? When we look at the theory behind the solar nebula, we notice that the solar system formed at approximately 5 billion years ago, which eliminates choices B, C, and D. The relevance of choice B, approximately 20 billion years ago, is when the universe first originated. And the Earth is much older than 250 million years or 600 million years. Your turn. Take time now to pause the recording and complete the following question. The solution will follow on the next slide. The question reads, explain the origin of the solar system according to the solar nebula hypothesis. The solution to the following problem, the preceding problem, explain the origin of the solar system according to the solar nebula hypothesis, will focus again on 4 stages. And be sure that you mention each of the 4 stages involved. The first stage states that a rotating cloud of dust and gas began to contract due to its own gravitational force. So the key point here is you have a rotating cloud of dust and gases, and they contracted under its own gravitational influence. The second point would focus on the material starting to rotate faster and faster, and as it rotated faster and faster, it flattened into a disk. So be sure to mention the material starting to rotate faster and faster, and it flattened into a disk. That's the key point for stage 2. Stage 3 focuses on at the center of the sun, or at the center, the sun eventually formed. Okay, within the disk, more concentrations took place, eventually forming the planets we see today. So be sure that you mention that within the flattened disk, more concentrations took place, which eventually formed into the planets. And the remaining point number 4 in this stage of the formation of the solar system, states that the remaining material was swept away by solar winds. So those 4 stages must be included when you address the answer to the question, the origin of the solar system according to the solar nebula hypothesis. Some common errors and misconceptions occur when answering this question. The first focuses on students not including all stages in the formation of the solar system. In past, students have mentioned 2, maybe 3 of the 4 stages, but marks are allotted for all 4 stages. So when you answer the question, be sure that you addressed each and every stage in the formation of the solar system. Another common error focused on students referencing the Big Bang theory instead of the solar nebula theory. So in summary, an overview of the points covered that explains the origin of the solar system according to the solar nebula hypothesis. When you're explaining your answer, explain each of the 4 stages. Stage 1, your main points, again, would be approximately 5 billion years ago, a mass of dust and gas began to contract under its own gravity. And as this contraction took place, it rotated faster and faster. Stage 2 focuses on the rotation caused by the material to concentrate in the center where it heated up and burst into a newborn sun. So the origin of the newborn sun, the protosun, will be a key stage to mention in stage 2. Then also you need to mention the remaining material orbited around the newborn sun in a flattened disk. Stage 3 would include temperatures within the rotating disk dropped, and as the temperatures lowered, small particles of iron and nickel started to form. As particles of iron and nickel started to form, they started to accrete or join together, where they formed into planets, moons, and other small bodies of the solar system. And the final stage in the summary of the solar nebula hypothesis is the remaining space between the planets started to clear with time, and most of the remaining debris was swept away by solar winds. So make sure that you mention the remaining debris in between the formation of the new planets was swept away by solar winds.